well. Okay, so let's clear this off now. That was a quick review. And let me get rid of this. Oops. Mouse. And I need to go back to this. And we're going to get our, actually, let's get our homework up first. If I come here, I'm going to go ahead and download that. Then I'm going to go to homework 1.1. Now, in general, when I looked to see where everybody was, most everybody seemed to do okay on like the first 5 or 6. Do we need to look at anything on 1 through 6 in this? Okay, nobody has finished the 1.1 homework. What I was noticing was probably around question 7 might be where some of the issues came up. So this one is the compound inequality. Do we need to go through how you would solve something like this? Okay, I've got some people shaking their head no here. What do you, and hold on a second, I need to get you guys up in Terrell so I can see you.
That's what we just did. Can you at least go over this one?
Yeah, we can go over this one. Hold on a second. And, oh, wait. Here we go. Okay, so on this one, let's look at it real quickly and remind ourselves how we do this. I'm going to see if I can, actually, let me do this first. I'm going to blow it up a little bit. Okay. And what's the strategy when we have these 2 inequality signs? We're going to have to do what? Remember, our goal is to get x by itself in the middle. So what are we going to have to do to make that happen? Very good. To get the x term by itself, I look at the middle and I say, I'm going to have to get rid of this -3. And the way I get rid of it is add 3. And if I add 3 in the middle, what else do I have to do? Very good. I have to add 3 on each side of the inequalities. That means there's 3 places I have to add it. So this, yes, if you're trying to get the x in the middle, and because you have 2 inequalities, it means just like we said with an equal sign, what you do on one side, you have to do to the other. If you've got inequalities, that's the same thing. I've still got to do it in all 3 places. So when I add 3, 5 plus 3 is how much? 8 is less than or equal to 4x is what's in the middle now, which is less than what's on the right side. 17 plus 3 is 20, right? Okay, now what? Divide everything by 4 because the 4 and the x are being multiplied, and I can undo multiplying with division. So if I divide everything by 4, that cancels. What number do I have on the left now? 2 is less than or equal to what's in the middle, which is less than what? 5. Now, that's what they want you to put in the inequality, right? So we would put in a 2 and a 5. And I'm not going to do that right now just because I'm kind of in this writing mode and I have to get out of it and type it in. But I do want to ask you, if you had to put it in interval notation, could you do that? All right, so let's talk about interval notation. Remember, interval notation is a way of explaining start here and stop here. And then we have to be careful about whether we use parentheses or brackets. Which one means that something is included? The bracket. squared off bracket. A parentheses means start here, but you don't include it. So when I look at this, I know I'm going to have a 2 where I start. I'm going to end at a 5 because all the x's are in between that. What would go around the 2, a parentheses or a bracket? The bracket, because of the or equal to. What would go around the 5? Parentheses, because there's no or equal to here. And that would be what it would look like in interval notation. Okay, give me a quick signal. Are we good with that? Carol, what do y'all say? Okay, let me clear. And that's another one that's similar. Now, the only problem with this one is there is a minus sign. That mess anybody up in doing these. What do you have to remember to do if you multiply or divide by a negative when there are inequalities? Flip the sign. Okay, so if you remember that, you'll be okay. But if you need more help, let me know. This is one that I noticed a lot of people kind of skip. And this is similar to what we just did, except this has some extra steps in it. We had a simpler equation that we solved for y. Let's make sure we could do this one. So if you had 2x minus 3y equals 6, and I want you to rewrite it so it says y equals. Let's see if you guys could tell me how you would get y by itself, okay? So if I start with 2x minus 3y equals 6, my goal is to get y by itself. What would you do first? James, can you help us out? How would you start this? James, can you hear me?
Mm-hmm.
Okay, so how would you start this? Any ideas? If I want to get y by itself. Is there something on the same side where the y is that I'd rather have it on the other side? My goal is to get y by itself. I want the only thing on that side to be terms that have y in them.
So just move the 2x on the outside of the 6.
Okay, I need to move the 2x, and we move it by doing what?
Subtraction.
Excellent. So I'm going to subtract 2x from each side. Okay, so that's going to cancel, and that leaves me with minus 3y, or negative 3y, equals 6 minus 2x. Now what? Divide everything by negative 3. Now, this did not necessarily tell us if we could make it one big fraction or if we needed to do each term separately as fractions. But if you remember, one of the things we talked about last time was if we'll divide each term separately, what we might find is some things reduce down and clean up. Is that going to help us here? Does anything reduce down? Yeah, 6 divided by negative 3 is what? Positive or negative? Negative. A positive divided by a negative is a negative. So I get a negative 2. And then what happens with this? I have minus 2x divided by negative 3. Say again? Well, I just need to clean up. First of all, will the fraction reduce? And 2 divided by 3 reduce down? No. But what about signs? Yeah, I've got a minus on top and a negative on bottom. And remember, a negative divided by a negative turns into a positive. So that becomes plus 2x over 3. Okay? Now, this one we'll try to type in. And let's see if it is okay with the way that I type it in. So if I type in negative 2, oh, hold on, that's the wrong place. Okay, negative 2. And then I want to put a plus sign. And then, let's see, I'll do it this way, 2x divided by 3. All right, and figure out, check. And it was fine. Okay, so as far as cleaning up this sign, I want you to remember any sign that's in front of a number stays with a number. So when we had this 6 minus 2x, that's the same thing as 6 plus a negative 2x. And so that negative sign is attached to the 2x, and it's divided by a negative 3. And what's a negative divided by a negative going to be? Positive. That's why it turns into a positive. Okay? All right. So far, we okay with that? All right, so let me clear that out. And I think this is, okay, another one. Do you guys want to practice this? Do you feel like you're okay with this? What am I going to end up doing when I need to get rid of this 8/7 that's in front of the p? Do you remember what the trick is to that? Okay, so if I have a fraction divided by a fraction, let me just kind of show you real quickly. Does everybody see what the first step would be if I'm trying to get p by itself? What would be the first thing I would have to do? Well, look carefully. Remember, I want to get the term that has the p in it by itself. So what else is on the same side with that needs to go away? Yeah, I need to get rid of the plus 28. So first thing I do is subtract 28 from each side. 2 minus 28 would be equal to 8/7 times p. Now, the problem here is if I already have a fraction and I divide it by a fraction by a fraction, if I do this vertically, looks really messy. So you tell me, if I had 5/3 and I wanted to divide, I'm going to write it this way instead of as a big fraction. If I wanted to divide it by 1/6, would you know how to do that? We reviewed this at the very beginning. What are you supposed to do if you have a fraction divided by a fraction? Leave, change, flip. And the flip part is the reciprocal. So dividing by a fraction is the same thing as multiplying by the reciprocal. So if I've got something written this way, if I do this, that looks like a gigantic mess, does it not? So what I want to do instead, and I'm going to erase this part, is I want to remember that dividing by a fraction is the same as multiplying by the reciprocal. So I want to multiply this by 7/8. So what's going to happen if I multiply 8/7 times 7/8? What happens if I multiply this? Why am I multiplying by the reciprocal? What will it do? Turn it into 1. But if I multiply the right side by 7/8, I have to do what else? Multiply the other side by 7/8. And so this is what p would equal to. And if I look at these choices, which one would be the correct one? A, B, C, or D? C. Because notice they wrote it over here without parentheses. If I don't put the parentheses, I'm going to have it wrong because the entire side has to get multiplied by 7/8. And I could distribute and clean it up, but I don't have to. Does that make sense? Watch out for that. If the number that's in front of your variable is a fraction and you're trying to solve for that variable, remember you can multiply by the reciprocal. Okay? And then I think we get up to some of these word problems. Do y'all want to do one of these word problems together? I think we should. And let's see if this will help us out. So let's do this. There we go. I'll move that there. So a jazz concert brought in $176,500 on the sale of 8,500 tickets. Some of the tickets were $15, some were $25. How many of each type of ticket were sold? So that's pretty similar to what we did last class. or that, well, not last class, but the last example we did at the beginning of class where we talked about the $10 bills and the $20 bills. But you guys talk to me. I want somebody to tell me if you recognize something. In fact, I'd say the best place to start is tell me what it is they're asking us to find. How many of what? Okay, how many of 2 different types of tickets? Does that mean I'm probably going to need 2 different variables? Yes. So if I let's see, let me pull this up a little bit. And if I let X be the number of what kind of tickets do you want? And it doesn't matter, just pick one. $15 tickets. Then what else should I write down? Okay, and what am I going to let that be? So Y would be the number of $25 tickets. Good job. Okay, now, since that's going to be what I'm looking for, look at the other information they've given us. See if you can tell me, do you think I'm going to need 1 equation or 2? Probably 2. Do you see one of the equations you know you could write? Excellent. Here's what she said. She said, I see that there's a total of 8,500 tickets. So she said X plus Y equals 8,500. Does that sound good to the rest of you? Make sense? Yes? Okay. Now, Carol, anybody see how to get our other equation we need? It's very similar to what we did with $10 bills and $20 bills. So think about it for a minute. All right, good. Sarah just said, if we knew how many of these tickets were sold, if we multiply it times 15, that would tell us how much money came in from selling the $15 tickets, right? Yes, ma'am. This number right here, right? Very good. Okay, so I had somebody suggest this is going to be the equation that we're going to try to solve. Yeah. Did this seem a little more comfortable than it did at the beginning of class? Good. Okay. That's why we're practicing this together. Think you guys can finish it? Go for it. I want to see if, and again, you can collaborate with each other. So Athens can work as a group, Terrell can work as a group, and let's see what you come up with. Say again? Oh, okay. Sorry, I misunderstood. Collaborating. Okay, when you guys think you have the answer, please let me know. Okay, anybody finished? Anybody have it in Terrell yet?
Okay, so what am I doing? No, I thought I did it all. Wait, where's this guy?
Okay, how we doing? All right, so I think we've got some answers in Athens. You guys got answers in Terrell? Yes, no? Dana, you got an answer?
No.
No? James, what about you?
I messed one up.
Daniel? Got an answer? Okay, so Athens people, you guys came up with an answer. What did you get? How many $15 tickets? Or are you not sure if you've got an answer? You said how many? 900. And what did you get for the number of $25 tickets? Okay, did anybody else get that? No. All right, do you have different numbers?
No.
Okay, so
I didn't even get to the base yet. I have
okay,
mine.
so 3,600 and what did you say for the other one? 4,900. Okay.
I have 7,000.
So sounds like we probably need to go through this together. Agreed? Okay, we've got the equations. So tell me, what do you want to do first after this? Because I have this equation here and this one. All right, good. We're going to solve for y. So you said you have to subtract what? Dx. Good. So if I subtract dx from each side, then I get y equals 8,500 minus x. And this part is going to replace my y here, correct? Okay, so then we went to 15x plus 25 times, and in parentheses is where I put 8,500 minus x. So far, are we together? Okay, then what? Distribute. Okay, so somebody tell me how much is 25 times 8,500? And that's a pretty, what? Yeah, 212,500, right? And then after I multiply that, I got to multiply 25 times this minus x. So that's going to be what? Negative 25x, and I could write it as plus a negative 25x equals 176,500.
The second number, you just automatically change the sign?
Well, I'm not changing the sign. I mean, if there's a minus sign here, I could write this as minus 25x. But remember, the sign that's in front of a number stays with a number. So I can always change subtraction to adding a negative, plus a negative, because it's the x that's negative, and when it gets multiplied by 25, it turns into that. So if you want to write it as minus 25x, you can, but just remember, when you're combining these terms, which is what we need to do in the next step, I'm really adding 15x plus a negative 25x, which will be how much? Negative 10x. So I have negative 10x plus 212,500 equals 176,500. Okay, now what? Minus the 212,500 from both sides. Am I going too fast, or are you guys okay? Somebody give me signals. You okay? All right, so a negative 10x equals in the 176,500 minus the 212,500 is I've got 36,000. Is it positive or negative? A negative 36,000. Now I would have to do what? Divide both sides by a negative 10.
Okay.
Okay, when I do that, I get what? I get what? First,
3,600.
I thought I had, oh, I'm sorry, because it was 36,000. You're right. And then when I divide by 10, I get 3,600. Which means that if I have $3,615 tickets, I can come back up here and calculate the $4,925 tickets. Now, how are we going to tell for sure if we did this right? Well, if we were to pull up a calculator, oops, let me do this. There's my calculator. Right there. Yeah. And if we did, this is going to be messy, but let's see what happens. If we did 3,600 times 15, that's 54,000. And then if we did, let me write that down, at 54,000 plus, and now I'm going to clear this out, and we're going to do 4,900 times 25. And that's 122,500. Add those together, do we get 176,500? So that's how we know we did it right. Okay? All right. Questions? How we doing?
It should be good.
Okay. So here's my question for you guys. Do you want to go through any more homework questions, or do you feel like you will be okay finishing up this homework now? We've looked at the inequalities. We've looked at word problem. We've talked about some strategies. We talked about how to solve for a variable. Are we good, or do we need more practice on this? What do you think? I got to get some kind of response from you guys. So,
Do number 12.
Absolutely. There we go. Because here's the thing. Let me just make sure this makes sense to you guys. I do not want anybody to feel like you are being dragged under the bus. You know what I'm saying? You're trying to get on and the bus is taking off and you're hanging on for dear life and you just can't figure out whether you're better off letting go, or if you keep hanging on, you'll eventually pull yourself on the bus. So if you start to feel like this thing is taking off without you and you need more clarification, let me know. All right. I don't want to move too slowly, but I don't want to move too fast either. So let's look at this one. And this is also kind of a similar type of question. The only thing that's a little bit different is we're talking about taking an amount of money and putting some of it, and this is more of a business application, in one account that earns a certain amount of interest, and we'll put the rest of the money in a different account that earns a certain amount of interest. So let's talk about this. You're going to take $250,000 in your IRA. That's what's there when you retire. So you can put some in a fund that pays 2.5% annually, and some in a fund that pays 7.5% annually. Now, you're probably thinking, duh, why wouldn't you put all of it in the 7.5%? What do you think the difference is in putting some in the 2.5 and some in the 7.5? Why wouldn't you just want to put all of it in the 7.5%? Because you are taking more risk for the higher interest rate. Okay, in other words, my 2.5% pretty much is guaranteed. My 7.5% might not be. Okay, so it's more at risk. So that's why we wouldn't put all of it there. So we want to try to come up with interest so we don't have to touch that $250,000, and we're going to need $10,750 at the end of the year. So you guys tell me, based on the question, what is it that I'm trying to find? Correct. How much should you put in each account? So I'm going to put some in Fund A. What would you want to call that? So X is going to be the amount in A. What else do I need to know? Very good. Y is going to be the amount in B. All right. So talk to me then about, when you look at this, do you see a couple of equations you can now write? So if X is the amount in A and Y is the amount in B, what's one equation? And feel free to speak up, Terrell. What would be one equation we could write down? We will, but before we do that, since this is the amount of money in A and this is the amount of money in B, how much total money am I working with? Excellent. So X plus Y is equal to 250,000, right? Okay. So I would start there. I've defined my two variables, and I know if I add that amount of money together, it's 250,000. Now, over here, we had a comment about we're going to have to do something with the interest rate here, because if you understand how interest rates work, if I'm going to get 2.5% interest annually on my investment, it means however much money I put in there gets multiplied by what? Does it stay in that percent form, or does it have to change to a different form? Has to change to which form? Decimal. Excellent. So I'm going to have to take the amount that's in A, but it's going to have to get multiplied by the interest rate, and it's 2.5%, which becomes, what is a decimal? How many places do I move? There you go. Got to move it 2 places, and that means if I have any empty spots, I fill in with a 0. So 0.025 times X plus, how much interest would I get out of what goes in account B? What's my interest rate there? 0.075 times Y. And how much do I want that to be? This is is my amount that I'm getting in interest. It needs to be how much? There you go, right there, 10,750. So we've gone through, to me, this is the hard part, is figuring out how to write the equations. Our process after this is pretty much the same every time. The only thing that changes is the numbers. Now, the one thing that's a little different here is we've got some decimals, but if you're using a calculator, you ought to be okay with that. So I'm curious, at this point, do you feel like you know what to do? Or do we need to continue to do this as a group? What do you say, Terrell? Could you finish from here on your own? Feel confident you can do that? What do you say, Daniel? Would you be okay finishing this from here on your own, or do you feel like we need to go through it together?
No.
No, as in, no, I can't finish it, or no, we don't need to go through it?
No, I can't finish it.
Ah, okay. So we're still a little fuzzy, evidently, on where to go from here. And I'm seeing some head shaking here too. So you guys talk to me. Once I've got this equation and this equation, what do I want to do next? Good. We start with this guy and we want to solve for y, right? So we subtract x from each side. And this is going to be our replacement equation for y. How many of you say, that part I'm good? Up here. What about Terrell? Okay. So that part we're good. And that means the only thing I'm going to do is come down here, and this y is going to get replaced with that. So 0.025x plus 0.075, and in parentheses, what do I put? 250,000 minus x. I don't change anything else in that equation. Right? Okay. What happens now? Okay, tell me what you mean. Yes. From here, we've got to distribute. So you got to multiply this times this, and then multiply this times this. Now I want you guys to do that, and then you're going to tell me what you write down on this next line to make sure we all did that correctly. I think that may be one of the places where we're kind of getting stuck. Okay, hang on a second. So Sarah's telling me she multiplied 0.075 times 250,000, and it was how much? Okay, so I've got somebody that confirmed that here. Is that what you guys are getting, Terrell? Because you need to make sure when you're putting it in your calculator, you're getting these numbers back. Now, what comes after that? All right, this is where we got to be really careful, because remember, you got to distribute the 0.075 times everything in the parentheses. There you go. Because I'm multiplying 0.075 times a negative x. You can either write it as plus a negative 0.075x, or you can just write it as minus 0.075x. Is that the part that we tend to kind of goof up on sometimes? Really careful that when you distribute, you multiply everything in the parentheses like that. Okay, now I'm curious. At this point in the equation, how many of you say, now I feel like I could finish the rest of it? I feel pretty confident, okay? A few hands here. What about in Terrell? Okay, still
yes.
quite sure. Okay, so talk to me about what you would do in the next step. Yeah, we got two terms that have x. We got to put these guys together. What are you going to get when you add those? Say it one more time. Very good. If I take a positive 0.025 and I add a negative 0.075, that gives me a negative 0.05x. x. Okay, because both of those were my x terms. Do it in your calculator to make sure you don't mess up. Plus 18,750 equals this number. All right. Where shall we go from here? Subtract the 18,750. And that means I have a negative 0.05x equals what number? Negative 8,000, right? Now what? In negative 0.05, we're going to divide both sides by that. Okay, put that in your calculator, and what do you come out with? 160,000. So you've got that x would be 160,000. What would that mean? That's the amount that's going to go in Fund A. What would be the amount you would want to put in Fund B? That's right. Plug it in right here. And if I take 160,000 away from 250,000, that would give me what? 90,000. It's going to be positive because a negative divided by a negative gives me a positive. Okay? And so let's type this in. Just make sure we've got it right. We're going to put in 160,000 in Fund A, 90,000 in Fund B. And the reason is we're trying to be cautious. So even though we're putting most of our money in a lower interest rate, that one's very secure, and I'm definitely not going to lose money there. And now if we check, we got it right. Okay. Let's see if you can finish 1.1 now and feel a little better about what you're doing, but don't hesitate to ask if you need more help, okay? So let's do this. Let's go back to our notes. And we started talking about what was in 1.2 last time. And I know most of you haven't looked at any of the homework in 1.2 because you're still working in 1.1. So we're going to kind of figure out how much of this we might need to review. Now, if we look at this, the first one was just showing something was a solution. And that was pretty easy, right? Because you just had to plug in. Tell me on this, what does the 0 represent in this ordered pair? X, very good. What would the -2 represent? Y. And we just put those numbers back in. And how do I know if it's a solution? What should happen? The left side of the equation would equal the right. So what we did was we said 2 times 0 minus 3 times -2. We checked to see if it would equal 6. 0 times anything was 0. A negative times a negative gives me a positive. And when we got 6 equals 6, we said, yes, that's a solution. Okay. So that's a quick review of what we talked about there. Now, we talked about standard form of a linear equation, which is this right here, that your x and your y are on the same side. Your constant or your plane number would be on the other side. And then we talked about finding your x-intercept and your y-intercept, because sometimes those are helpful in graphing. I'd mentioned to you, though, there was a quick way to tell if using intercepts was a good idea. Do you remember what you would need to look at in this equation to decide if using intercepts made sense? We're on the first bracket I gave you, the one that says deco on the top, and we're at the part that says review for one. Sorry. Yeah, we pulled off that and we went to 1.1 last class, but now we're back in the deco packet. So do you remember how we discussed what would be your test to figure out if using intercepts would make sense? If it's in standard form, look at what? Well, that would be slope-intercept form, and and we're going to talk about how to graph that way too. But if I just wanted to know where does this thing cross on the x-axis and where does it cross on the y-axis, if I'm in standard form and I check and this coefficient in front of the x goes evenly into this constant over here, does 3 go into 12 evenly? Yes. And if this constant in front of the y, or this number in front of the y, the coefficient, will divide into that constant evenly. Will 4 go into 12 evenly? Then that's when finding intercepts is a quick way to get it graphed. And the way we do it, if I'm looking for my x-intercept, you let y equal 0. So I would do 3x minus 4 times 0 equals 12. And what's 0 times anything? 0. So that means I get 3x minus 0, which is 3x. And if 3x equals 12, what would x equal? Because I'm going to divide both sides by 3. And that means x equals 4. So my x-intercept is going to be the ordered pair when x is 4, y is 0. So we talked about starting at the origin. My x value is positive, so I go to the right, 1, 2, 3, 4, and I put that point on there. All right? So how do you find your y-intercept? Except you let x equal 0. Very good. Same process, but now let x equal 0. So if I do that, then 3 times 0 minus 4y is going to equal 12. 0 times anything is 0. And that means if I'm trying to solve negative 4y equals 12, I do what to each side? Divide by negative 4. And what would that tell me that y equals? Negative 3. So what that tells me is my y-intercept is when x is 0, y is negative 3. So since x is 0, I don't move right or left, and my y is a negative 3, so I move which direction? Down. And now that I have 2 points, can I draw a line? Exactly. Now, I did caution you that there is one drawback to when you only use 2 points. You remember what it is? If I made a mistake, I won't catch it because I can make a line go through any 2 points. What did we say was sort of a helpful thing to show us if we've done it correctly? Instead of only using 2 points, we could use how many? 3. Because if it looks like a triangle when I use 3 points, that tells me I've done something wrong. If it lines up and looks like it's a straight line, then we're in good shape. Okay? All right, so we're going to try to move through this fairly quickly since we talked about a lot of this last time. We did skip this, so let me cover this with you. I need to graph these 2 lines on the same coordinate plane. Now, one thing you're going to notice that looks a little funny is tell me if this equation is x equals negative 4, how do I graph that? I don't see an x and a y. Like a minute ago, we were putting in, I'm seeing this going on over here. Do you guys recognize if I have only one variable, the line is either horizontal, which means that it goes this direction, or it's vertical, and that means it goes this way. Here's how you tell which way this thing graphs. This is saying all x values on this line are negative 4. My y's can be anything, but all the x's are going to be negative 4. Now, I could make a table And I could put -4 down 3 times and pick any 3 numbers I want for y, plot those points and draw the line, or this is kind of the shortcut. Since all the x's have to be -4, what that tells me is this line has got to cross the x-axis at -4. So where x is -4, right here, this line is going to be x equals -4. Pick any point on here. What's the ordered pair that goes with that point? What's the x value for this point right here? -4. What's the y value? Well, if I'm just counting by ones, this would be 3. Yeah. Pick another point. What would be this ordered pair? The x value is -4. What would be the y coordinate? -2. So that's to me, the easiest way to do it. If there's only one variable and you're supposed to be graphing a line, it's either going to be vertical or horizontal, and it's going to cross the axis of the variable in the equation. So x equals -4 crosses the x-axis at -4. Where do you think y equals 6 needs to be? It's going to be this direction because it's going to cross the y-axis. So all I have to do is go to 1, 2, 3, 4, 5, 6, which actually happens to be this very top line here. And that would be y equals 6. Make sense? So those are easy once you understand that's all you're supposed to do. Okay? And then we talked about slope for a little bit. Remember we said slope is kind of like the idea of pitch on a roof or grade on a road if you're going up a hill or down a hill. And so slope is talking about the change in y over the change in x. In other words, as we're moving from left to right, what we're trying to tell is how quickly is it going up or how quickly is it going down? And that's a helpful thing to know. So if we were to look at this, we have a formula for slope. It means as long as I've got any 2 points, I can calculate the slope if I take the difference in the y's divided by the difference in the x's. And I just have to be sure that whichever ordered pair I start with first, that I come back and get the x value out of that ordered pair first on bottom, okay? And I believe we did this one together last time, and it kind of had a special result, because if this was x1, y1 in the first ordered pair, and this is x2, y2 in this ordered pair, and it doesn't matter which one I call, I can change and make this one x2, y2 if I want, but since I saw it first in the list, that's why I'm using 1 as my subscript to find my slope. And known as the letter that represents slope, we plug into this formula, y2 minus y1 over x2 minus x1. And that means what goes in for y2. I'm going to put parentheses minus parentheses over parentheses minus parentheses. I'm going to put the numbers from the ordered pairs inside these parentheses. And I want to be really careful I don't make a mistake with signs. So what would you put in here for y2? 4. What would you put in for y1?
4.
Yeah, it's also 4. Over, now what goes in for x2? Good. I have to come back to the same ordered pair where y2 was and get the x value that went with it. So that looking at it this direction, that was the original ordered pair. What goes in for x1? Very good. That's why you got to be very careful you don't mess up on signs, because if you don't put the parentheses, you may think you've already got a negative sign here that goes with that -2, but you don't. That's a subtraction sign, and then you have to put -2. And like Sarah said, that's going to turn into addition, because minus a negative turns into adding the opposite, which is plus a positive. And so when you clean this up, 4 minus 4 is how much? 0 over in my denominator is 5. And let's see if you remember this, because we talked about it last time. What's 0 divided by anything?
0.
Exactly. 0 on top cleans up to be 0. Remember, we talked before about in a division problem, this times your denominator should equal your numerator. And would 0 times 5 equals 0? Yes, because 0 times anything equals 0. The problem we have is if we end up with 0 in the denominator. If this had happened to be 0 on the bottom, then what number times 0 would equal 5? What number times 0 would be 5? Can I do that? There's not a number. Because if I multiply any number times 0, I get what? 0. I can't get a different number. So there's nothing that could be multiplied times 0 to give me 5. So when 0 is in the bottom of a fraction, remember that is undefined. It's impossible. I can't do it. Okay? And that's going to tell me that my slope is actually vertical, because I would end up with 0 on the bottom if I tried to find the slope on that line. So there is no slope that exists on that. Okay, now let's see if we could actually sketch this and figure out the slope. So first of all, if it didn't give me anything to sketch the graph, would I know how to find the slope? Because I could use the formula, right? And so we'll use that in a second, but I want, can I get a volunteer to come up here and actually put these points on the coordinate plane for me? Yeah. You can write on my Surface Pro. Okay, so we're going to put the ordered pairs -2, 4, and then +3, 4 on the coordinate plane. See what this looks like. So all you have to do is just put, so I know, kind of sensitive. Hold on a second, go back to the, and that's okay, let's just do this.
That's it.
Yes, the X's have to go left or right first, and then we want to go to, actually, let's do this.
Is it writing?
I don't think it is. Let's do, here, let me fix it for you so it'll write. Okay, so now, okay, well, all right, let's just go ahead and I think when you put it on there, it'll work. So -2, +4. That's the actual point we want, right? And so what I'm going to do
What about this?
that, because that's not the part we want, but that's fine if that helps you get there. Now let's see. I don't know why that won't here. Okay, and then we'll go back. Okay, now see if you can put 3, 4 on there. Mm-hmm. Excellent. Thank you, Sarah. So she put these 2 points on here, and if I were to connect these, what kind of line do I have here? How would you describe that line? It's horizontal, and this is actually the ordered pair we found the slope of a minute ago when we used the formula. And what did we say the slope was? Well, this one had 0 on top, and when 0's on top, our slope was what? 0. Okay, so if we were to plot it, that's what we would know. A slope of 0 means your line is horizontal. If your slope is undefined, then your line is vertical. Okay? Those are some things you want to kind of tuck in your brain. That's going to help you out. And then we're going to look at some illustrations of slope. I'm going to clear this off right now. And this is what I want you to be sure you understand, because this sort of helps you whenever you're working with slope. And if you know that the slope is supposed to be positive, what that means is as you're moving from left to right, this line is going to be going up. Okay, that's a positive slope. If I'm moving from left to right, the line is going down, means I have a negative slope. Yes. Yes. Sure. The slope, if you get a slope of 0, it means your line is horizontal. Slope of 0 means your line is horizontal. So it's the equation that would be a y equals something. If you get a slope that's undefined, it means when you plugged into the formula, you got 0 on the bottom. That tells you your line is vertical. Okay, so those are our two special cases here. And what this means is if my slope is 0, the x values match in the two ordered pairs. If my slope is if my y values match, then my slope is 0. If my x values match, then my slope is undefined. Okay. All right, now we're going to talk a little bit more about slope-intercept forms, because we were working with that earlier. It's when you get y by itself. Y equals mx plus b. And we said that the m is the slope, the b is the y-intercept, and I believe we talked about how we could graph this particular equation this time, correct? This one I believe we did. So what I would want you to do is make sure you would know how to get this out of slope-intercept form and get it on a graph. And tell me again, the only numbers I see here, I've got a negative 2/3. That's right in front of the x. What does that stand for? Slope. Very good. And at the end, I see -3. What does that stand for? That's my b, which is my y-intercept. Now, the idea is, as long as I know a point on the graph and the slope, I can get the graph of the line on it. But I can't do anything with slope until I put on the point. So if this is my y-intercept, where would I put the point? -3 on which axis? Exactly. If it's my y-intercept, I've got to go down 3 on the y-axis. That point is actually on my line. Now, how do I use the slope to help me find another point? My slope is a -2/3. You do the rise over run. So tell me how I could move from this point using my slope to find another point on my line. Well, remember, since you said it's rise over run, here's what I used to tell students. I would sit down, and you people in Terrell, unfortunately, don't get a real clear visual illustration of this. But if you were sitting in a chair and I was trying to illustrate slope, would I need to stand up before I could run? Yeah, so that's the rise has to come first. So that's going to be your up or down. And I'm going to go up or down 2 first. Then I can run, and I'll go right or left 3. And I'm going to use the signs in here to help me know which way to go. And remember, if I have a negative sign in front of a fraction, I can either put it with the top or I can put it with the bottom. That's my choice. So tell me, that means there's 2 different ways I could start here. What's one way I might want to go? Down 2, and then what? Over which way? 3. To the right 3. 1, 2, 3. And that point would be on my line. Now, I could also, from this point, have gone which way? Instead of going down 2, I could have gone up 2, but then which way? To the left 3. Remember, if I have a negative sign, it tells me one of the moves is going to be a negative move, the other one's going to be positive. So I could go down 2, right 3. I could also go up 2, left 3. And does this look like a line? Yes, it does. These points line up. And then here's my question for you. If I were to ask you, is this slope increasing or decreasing? Is it going up or is it going down? What would you say? And does that make sense since my slope was negative? Absolutely. Very good. Now, if they told me the slope and they told me the y-intercept, I could put that into an equation because my slope is which letter? The M or the B? The M. That means my y-intercept is the B. So if I tried to take that and put it into y equals mx plus b, what's going to be my equation? Y equals what? I'm asking right here with this information, it says write the equation of the line that has a slope of 2/3 and a y-intercept of -2. So how would I put that into an equation? Y equals what? 2/3 x, and then I can put -2 at the end or plus a -2 at the end. Okay, give me a quick signal. I know we've covered a lot already. Are we still okay? All right, excellent. Let me clear this off now. And I'm curious, is some of this coming back to you guys? Are you remembering some of this from high school algebra? Hopefully, yeah. There's one more type of equation that is helpful to know. And let me just kind of review you on what we've covered so far. We said standard form is when we have both the x and the y on the same side, and then we have our plane number on the other side, right? We said slope-intercept form is what? You can tell me again. Starts off y equals, what's our mx plus b? Good. Where m is our slope, b is our y-intercept. And remember I said as long as you've got a point and the slope, you could graph your line. It's also true, as long as you have a point and the slope, you can write an equation. But what if the point that they give you is not the y-intercept? It means we need a different formula, and it's this one, point-slope form. And our formula is, I'm going to write it down for you here, although it's in the box. Point-slope form means if I take, and let me show you where it came from, just so this sort of makes sense. We said that you find slope if you were to take the difference of your y's over the difference of your x's. Now, the only thing that's different here is instead of using subscripts for 1 and 2, that's when I know what the values are. I'm just going to say, I don't know what point, this ordered pair is, but I know that one. So my slope would be whatever that y is minus the y of the ordered pair I know over x of whatever point I don't know minus the x of the one I do know. Now, do you guys remember something called proportions? Remember cross multiplying? If I have a fraction equal to a fraction, then I can multiply this way. My m would be multiplied times the x minus the x1. And then I multiply this way. And that would equal the y minus the y1. If you look up here, that's exactly the formula we have, just on different sides of the equal sign. So y minus the point taking the y coordinate, is equal to the slope times x minus the x coordinate of the point Okay? So there's 3 different forms of linear equations, and it kind of depends on what you know, what's going to be most helpful to use. Now, before you get too freaked out, you're going to get a formula sheet that will have these equations written on it that you can use when you test. You're probably going to get them memorized because you're going to practice them. But I'm not requiring you to memorize them, as long as you can look at the formula sheet and say, oh, is the one I need, you'll be okay. All right? Any questions so far? Are we okay? All right, so let's look at an example using point slope form. So let's say the point they give us is not the y-intercept, but it's just some random point that's on the line. So my point is negative 4, 3, but I do know I have a slope of 1/2. So can I come up with an equation for that? So which form do you think we need to use? Can I plug right into standard form? Can I plug right into slope-intercept form? Can I plug right into point slope form? Which one do I need to use? Point slope, there's a big clue right there. All right, so we're gonna take y minus y1 equals m times x minus x1. And if that's the correct form, that means I should know the number to plug in for m, and I should have an ordered pair where I know the x and the y value. And I think I have that. Because here's my ordered pair, that means this is my x1, that's my y1. My slope is my m. So let's see if you can tell me how you would plug into this. Y minus, now what's going to go in for y1? 3. Equals, what was my slope? 1/2. And then in parentheses, I've got x minus, now what's going to go in for my x1? Well, if I'm plugging into the formula, I'm actually putting in a -4, and then you're a step ahead of me, Sarah, because you're trying to clean up. And what happens when I have minus a negative? It becomes plus a positive. Good job. So I have y minus 3 equals 1/2, and then in parentheses, x plus 4. Now, it's telling us to put it in standard form. I'm not going to require you to do that. If you can get it into slope-intercept form, then you would be able to graph it. Of course, if you know the point and the slope, you can graph it as well. Let's just see if we could put it into, instead of standard form, let's put it into y equals mx plus b form. So what would I need to do to kind of clean this thing up? I want to get y by itself. Do I want to leave the parentheses? No. So can you help me distribute there? I'm going to have y minus 3 or 1/2 times x, 1/2 x. What's going to follow that? Finish using the distributive property. Because I'm going to have to multiply 1/2 times 4. And if you need to, come over here or put it in your calculator, and 1/2 times 4 is 2, right? What would be the last step to get it into y equals mx plus b form? Add 3 to both sides. Very good. So if I add 3, then I'm going to get y equals 1/2 x, and this becomes what? Plus 5. Are we good? Give me a signal. How comfortable are we at being able to plug in, move things around? Okay, I'm seeing some thumbs up here. How about Terrell? Okay, good deal. Dana, are you still okay?
Yeah, I'm done.
Okay. The only thing that's different on this next one is they didn't tell me the slope, but they told me 2 points. Could I find the slope if I know 2 points? Yes, because I could use the formula for slope, and then I can pick either one of these 2 points and do what we just did. So to save a little time, is it okay if we say we don't necessarily have to do that one in the notes? We can come back and do it next time if we really need to. But I'd like to cover just a little bit more before we take a break and head to the lab. This gives you a quick review of everything we've talked about related to these linear equations and what those lines would look like. or what type of line they would be. So this kind of is a little go-to if you need to review a little bit. And let's talk about a cost equation for a second. Remember we said there are some basic things in business that would be really helpful to know. If I own a business, wouldn't it be a good idea if I understand what all of my costs are? I mean, it's going to be hard for me to figure out how to be successful in business and make a profit if I don't know how much everything is costing me. But are there two different kinds of costs involved? Are there fixed costs that I have to pay no matter what, and some variable costs? You understand the difference? Fixed costs are what? Things you have all the time, you can't change them. You're going to pay rent every month, no matter what. You're going to pay utilities. Now, they will change a little bit depending on, you know, how much electricity you use, but you're going to have to pay the electric bill whether you sell any of your products or not. But your variable costs are things that change based on how many you're making, how many employees you hire, you know, what you have to spend on your supplies, things like that. So you've got to be careful to recognize how to calculate your costs. And if you own a business, what do you think you'd want to do with your costs? Would you want to make them maxed out? Do you want to spend as much as you possibly can, or do you want to minimize your costs? What do you say? You'd want to minimize your costs. I mean, you're going to make more profit if you can be very efficient and minimize your costs and increase your revenue, right? So cost equations are important to know. This says a company that manufactures skateboards has fixed costs of $300 per day. So they've actually calculated based on what we have to spend every month. That's $300 a day. And our costs of $4,300 per day at an output of 100 skateboards per day. So it's telling us to assume that cost is linearly related to the output X. In other words, if I were to try to put this thing into an equation, it's going to be something that's linear. That, in other words, my costs are going to increase at a steady rate, or they're going to be decreasing at a steady rate, okay? So the first thing it asks us to do is to find the slope of the line that would join these outputs of 0 and 100. That would mean it's the line that would pass through the points 0, 300. Remember, if I don't sell a single skateboard, if I have 0 income, I still have expenses of $300 a day. But they've already calculated up, if I'm selling 100 skateboards, it's costing me $4,300 a day because I've got an extra $4,000 that gets added onto that 300. Okay, so tell me how I'm going to find slope if that's what they're asking for. We're going to have to do the difference in the y's. Usually we write it as y2 minus y1 over what? x2 minus x1. Very good. Does it matter which one of these I call x1, y1? No, but probably most of us are going to label it in the order we see it. So if this first ordered pair is x1, y1, the second one is going to be x2, y2. So when I plug in, what number would you put on top first? What would you put in for y2? The 4,300 minus what? 300. What number goes in first on bottom? What would we put in for our x2? 100. And that would mean our x1 is 0, right? So how much is 4,300 minus 300? 4,000. Divided by, what goes on bottom? 100. And if I clean that up, that is going to be a slope of what? Say it again. Yeah, because if I divide out both numbers by 100, makes those zeros cancel. And so my slope is 40. Okay. Could I now come up with an equation for cost, where X is my output, how many skateboards? So, I mean, I already know if I make 100 skateboards, that it's costing me $4,300 a day. Could I figure out, if I want to make a different number of skateboards, an equation that would let me calculate it, no matter how many skateboards I'm making? Remember, I got to have 2 pieces of information to do it. What are 2 things I need to know? I know, I realize we're kind of at the end of what your brain can absorb, so we're going to stop after we finish this example. Think about all of those linear equation formulas we just looked at. I got to have a couple of pieces of information to write any of those equations. What's one thing that I need to be able to write the equation? Again, if I have a point, you're right, I need a point. Can it be any point? It can be, or if I know which special point, do I have a shortcut? Which point do I need to know if I want to use the shortcut? Well, the slope's not a point. The y-intercept, exactly. If I know that special point, the y-intercept, I can go straight to y equals mx plus b. If the point that I know is not the y-intercept, I could use point slope. But on either of those, besides a point, I also have to know what else. What do they both have in them? Slope, right? So I need to know the slope, and I need to know one point. So I now have the slope. Here's my question. Do I know the y-intercept? How does the y-intercept look as an ordered pair? Remember when we looked before and we were trying to find the y? Say it again. It's when x equals 0. Do I know that point? Look at the 2 points I have up here. Look at that. They actually told me the y-intercept. Now, if I didn't want to use that and I wanted to use 100, 4,300, I could plug into point slope form and I would get the same equation I'll get by using the y-intercept, but it makes it a lot easier if I know the y-intercept, because then that's my b. And if I want to plug that into y equals mx plus b, that means my equation for cost is going to be what? Y equals 40x plus 300. Now that would be helpful, because let's say I want to increase the number of skateboards that I'm going to produce. I need to figure out, if I'm going to make 150 skateboards a day, how much is that going to increase my cost? I can do that now that I have this equation. If I need to slow down, maybe I'm running short on cash and I just can't make 100 a day anymore, then I can figure out what my cost would be if I'm only making 75 skateboards a day. Okay. So here's what I want to do is I'm going to take this equation and I want to graph it. So let me pull this up just a little bit. Okay. And I'm going to do this differently because everything in here is positive. And so when we're graphing things that relate to the real world, usually we're just looking at the first quadrant because everything's positive. I mean, can I make a negative number of skateboards? No. Am I going to have a negative number of dollars that it's costing me a day? No. So everything is going to be positive. And I've got to come up with some sort of scale that I can use so that I can, it has to be an even scale. Now by that, what I mean is I got to use the same units on the x-axis all the way across. I can't count 1, 2, and then jump to 50 and 100. It's got to be this, count the same way across the x. I can count a different way on the y, but it has to be consistent on the y. So notice it said, I want my x's to be between 0 and 200. So if that's 0, then I could make this 200 right here. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units here. So 1, 2, 3, 4, 5, 6. This could be 100 right there. 1, 2, 3. That could be 150. 1, 2, 3. That could be 50. Okay. You don't have to count that way. You can count a different way, but that at least gives me some consistent use for my x. Now my y's, I'm going to want to count differently because look at this. My starting point is 300. Remember, that's my y-intercept. So I'm kind of thinking that I may want to do this very differently because look at this. My 40 is going to get multiplied times the number of units. And the one that we had an example of was 100, and it went all the way up to 4,300. So what that tells me is this is going to go up really fast. All right, so maybe what I would want to do is count by 5,000. Okay, so if that's 5,000, 10, 15, 20,000, 25, 30, 35, 40,000, 45, 50,000. We'll kind of just see where we end up with this, okay? And this is, you can pick, you can count by something different, but I just want to see what this is going to look like when I put it on the scale. So what I do know is that the ordered pair 0, 300 goes on here. Now, if this first line is 5,000, is 300 going to be pretty close to the origin? Yeah. So I need to put a point here. And then 100, 4,300, 100. Oh, you know what? I'm so sorry. I have put, I goofed on that. This needs to be 500, and that needs to be 2,000, and this needs to be 4,000, and this needs to be 5,000. Sorry, I put an extra 0 in here, so let me fix that. So when I go to 100 and I want it to be 4,300, here's 4,000, that would be 4,500, so 4,300 is up here. I could pick some more points using that, but that would give me enough points that I could put the graph on there. And that would tell me, that's a pretty steep slope, wouldn't you say? Okay, so guys, I realize we really pushed it to the limit today, trying to get through some of these notes. We did not quite finish our review on 1.2, and the homework is set up to where it's review of 1.2 and 1.3. So what we're going to do is start in on that, where we might run into some stuff that we will need to back off of until we meet next Monday. But let's see how far we can get, okay? And hopefully, then when we go through our notes that go with the actual homework for 1.2, this will help us get through it a little easier, okay? So we're going to head to the lab over here. You guys and Terrell, you can start working on homework. I'm going to leave my laptop turned on, so you can ask questions if you need to. Anybody have any questions right now? Thanks for your patience. I will try not to wear you out this much next time, okay? All right. Let me clear and close this out. And yes, the recording.